Okay, this is lab 5, part 6, and we were able to use the code from the book on page 190 to 191. And this is basically a little game with the timer that when you see a light flash, you push the timer and it tells you how long it takes you to press it. And this is the code that we put on there. We had to modify it a little bit because we only have one LED light instead of two. And our setup is still the same setup as previous. And you can see that we hit this. I'm gonna wait for that light to flash. And then I hit it. And then over here, it tells us how fast we were able to hit it.
Okay.
All right, this is lab 5, exercise 5, and we use the debounce function to help with our using an LED with a button. And this is our setup. It's the same as the setup in part 4. Our code is just use the code from the slides, and you can see that we have a debouncer right here for 200 milliseconds. So that means when we hit our button, it'll wait 200 milliseconds, and then we shouldn't have the flickering every now and then. It should just work. And so as you see, we hit our button and it just turns on, turns off, on, off, without any bouncing around to have it back on or off. Okay, this is lab 5, exercise 4, using an embed interrupt library to toggle an LED with a push button. And this is our setup. We have our pin 18 connects down here to a push button, and then on the opposite edge we go up to ground, and then on pin 5 we hook, V out, not ground. And then on pin 5 we hook to an LED, and on the other side of the LED we take that back to ground. Here is our code that we just got from the slides. You can see that it's just going to toggle that LED when we're hit the button. At least that's what it's supposed to do. And so we come over here and we hit the button and it turns on. We hit the button and it turns off, but there's probably a bounce effect happening because if I hold it, it'll turn on and off. I just have to hold it to get past the bounce effect. Otherwise, it's just kind of irreliable.
Two tickers to control our waveform.
This is lab 5, exercise number 3.
Timers that we had before, so our hookup's still the same.
So our setup is still the same. We just have just the same as exercise 2.
This time.
And we're using interrupts this time, and here's our code that we just got from the slide.
I think it's just
and the only problem that we did find is there was a weight here at the bottom, and we had to get rid of that weight.
Messing around with one of these,
and
which is this. I think if we
yeah,
just
we got
get
rid of that.
this one.
And here is our oscilloscope again. I'm going to hit stop, and we're going to see that there's going to be 5 of these. 1, 2, 3, 4, 5 for one period on the bottom, which makes sense for being 0.2 for the number 1, the first flipper, and then 1 for the second flipper. And that shows the 5 inside the 1. All right, this is lab 5, exercise number 2, using 2 timers and using the oscilloscope.
If I hit this,
so our setup, we just had to add one, just on pin 6, we just had to add another wire and a lead up to the oscilloscope.
You have 2 channels on the oscilloscope?
Yeah. And our code is almost the same as the first code, except we had to add another digital output for pin 6, and that's our timer number 2. And then we just had to do another thing for timer number 2 to read for 1,000 milliseconds, and then timer 1 still 200 milliseconds. And we look at our oscilloscope. If we hit stop, this is a 1 full period, so you can see here is 1 period for the 1, 2, 3, 4, and 5, and that's 1 period for the bottom, and that makes sense because this is 1,000 milliseconds, and this is 200, and there'll be five periods for the 200 inside that 1 period for the 1,000.
Okay.
This is Taylor Wells,
Ebraheem Alhendi.
and this is for lab 5, exercise 1.
They told me, I was like, oh my gosh.
This is our setup. All we have is basically our ground is right here, and our pin 5 is right here, and we connect this to our oscilloscope.
here, and this
And-
is.
Yeah, this is the code for it. It was just basically copied and pasted from the slides, and our time is 200 milliseconds, and so we come up to our oscilloscope, and it's giving us a nice square wave, and we're actually getting 400 milliseconds for our period. So that kind of tells us that the 200 milliseconds in our code is just half the period.